All right, in this video, I'm going to go over example 4, 5, and 6 of section 4.3, okay? Example 4, so we are evaluating this definite integral, and they gave me a graph. So that's, looking at the graph, what I'm noticing is this already. The answer is going to come out to be negative. Why do we know that? Because, look, there is more area below the x-axis. By the way, what is wrong with this picture? Why is my 3 over here sideways, looking like a -3? I don't know what happened. Maybe when I was because I took a screenshot of this and then I pasted this onto this document and then maybe I accidentally flipped it. But either way, it looks like I didn't flip upside down because that's still +3 and that's still -3 down there. So I got more area below the x-axis, and then I got less area above the x-axis. So, because it wasn't flipped upside down, it was just flipped like right, left, you know. So, sorry about this weird looking numbers on the scale. Yeah, that's probably what just happened. But as you can see, below the yellow shaded region is slightly bigger. So what we are going to expect is the answer is going to come out to be negative. So without even doing this, I know that there is more area below the x-axis than above it. I know that because it looks like that. But, you know, we should evaluate this definite integral and see if the area really comes out to be negative, okay? So let's evaluate this integral. I'm going to use the power rule, okay? So x to the third power. X to the third power. This will turn into what? X to the fourth power divided by the new power of 4, okay? All right, and then the next one, I'm going to do my minus 3x. 3x, I have to increase the exponent by 1, so that's going to be 3x squared, and you must divide it by the new power of 2. That's it. And no worries about the plus c because we have bounds to plug in this time. Remember the notation, we kind of draw the parentheses, like the square looking brackets around. And then the notation is you put the upper bound on top corner and then the lower bound over here. And what we are going to do is we're going to plug in 1 and -1/2 in, and we're going to just subtract those two answers. Ready? So let me go ahead and do plug in 1 into x first. Okay, let me go ahead and plug in 1 into x first. Okay, that's my plan. I will have 1 to the fourth power over 4 minus 3 times 1 squared over 2, right? That's what I got for plugging in. That's what I will simplify after plugging in 1. Now, what are we going to plug in? We're going to plug in -1/2. I'm going to plug in -1/2 into x this time. But remember, we are subtracting, right? We're subtracting these two quantities. So I will have -1/2 to the fourth power over what? 4 minus 3 times -1/2 squared over 2, okay? So let's go ahead and evaluate this fraction, subtraction. Let me do the first green ones. This will simply be 1 over 4 minus. Now, this will turn into, because 1 squared is just 1, 3/2, right? But let me rewrite this 3/2 as 6 over 4 so that I can match the denominator with the first one so that I can subtract, okay? All right, let's go to the purple one. Do the inside the parenthesis first. What I'm gonna get is, now look, if I cube, hold on. If I raise -1/2 to the fourth power and divide it by 4, I'll do the work over here and then I'll put it there. Then I'm gonna get, first of all, if you raise something to the even power, that's gonna turn into positive. So I will have 1 over 2 to the fourth power is 2 squared, 16. And then I'm dividing that by 1/4, which is the same thing as multiplying by 1/4. Dividing by 4 is the same thing as multiplying by 1/4. So if I simplify the first fraction, this complex looking fraction, I will get 1 over, what's 16 times 4? 64? 64. So I will get 1 over 64 for this first mess. And then the second one, let me do the work over here. 3 times negative 1/2 squared divided by 2, right? That's what that fraction is saying. I will get 3 times positive 1/4, because if you square that, divided by 2, and that is 3 to the 3/4 times 1/2, and that is going to give me what? 3/8. Now, I want to make sure that these two fractions have common denominator, so how about I rewrite this as something with 64 in the bottom. 8 times 8 is 64, so 3 times 8 is 24. So I'm going to have 24/64 over here. Now look at us. We're not getting any rusty in our fraction skills. So, because you know, guys, you're going to be back in classrooms in fall semester if you have to have another math class. And if you're used to doing everything on your calculator, you know, we don't want to lose our math skill, okay? So the first one, if I subtract, I will get -5/4, right? And then if I combine the next one, I will get, what's that going to be? -23/64? Okay, I'm almost done. Now, let me go ahead and rewrite the green one so that it has 64 in the denominator. What's that going to be? Hold on 1 second. So I'm going to do 64 divided by 4, which is 16. And 16 times 5 is 80. So the first fraction, the green one, is -80/64. And then finally, well, this will turn into, notice, this is a subtracting a negative. I'm going to go ahead and write this as plus 23/64. So what's our final answer? If I do -80 plus, if I do 80 plus 23, then I'm going to get -23. -23/64. And that is the, hold on a second, that doesn't look like it. Because I'm using this tiny iPad or MacBook calculator, it gave me something wrong. 80 minus 23 is 57. That sounds more like it. -57 divided by 64. And that is my final answer. This is the area that's shaded on this graph. And see, this did come out to be negative, right? And that's okay. As we expected, right? Because we had more area below the x-axis, so we are going to get a negative area. So, and you know, what's great about us having this technology is that you should be able to check your answer. Okay, you should be able to check your answer on your TI-84. One of these calculators, they will all do it. So what I'm going to do is I'm going to go ahead and let me see if I can take a picture of this problem before I go out to my app. Where's my phone? Okay, I'm just going to come back a couple times, I guess. I'm going to go to my calculator and then go ahead and type in the definite integral that I just evaluated by hand. Was it x cubed? Yeah, I think so. X to the third power. That's all I remember. I'm horrible with memories. X to the third power minus 3x. Okay. X to the third power minus 3x. And then it's dx. But then the bounds, I remember those. The upper bound was 1. The lower bound was -1/2, wasn't it? Okay, and I hit enter. Oh, well, they gave me a decimal. I don't want that. Well, it came out to be negative. That's the good news. Math, and then I converted into fraction. -57/64. -57/64. Yay! So, no, I just kind of used that TI-84. I don't know what that one is called. It was a free app that I downloaded. I used that to kind of check my answer, and it came out looking good. So that's what you can do, guys. That's if you have a calculator that you want to just check your answer. But please don't try to evaluate the whole thing without doing any work, because I don't want you to get rusty on your math skills, okay? All right, let's do 2 more problems. 5 and 6 are application problems. So first one, business. And then example 6 will be physical science example. Let's look at example 5 first. Total profit from marginal profit. Northeast Airlines determines that the marginal profit is in hundreds of dollars per seat. Now, we better look at these units carefully. When I find the answer, I'm going to remember to multiply by 100 because this is in hundreds of dollars per seat. From the sale of X seats on a jet traveling from Atlanta to Kansas City is given by, here's my function. They gave me my, and it's not a profit function, isn't it? This is a marginal profit function, right? So if I want to find the profit function from the marginal profit function, we're going to have to integrate this, right? So what do they want? Because I was like, should they give me an initial condition so that I can figure out C? No, we don't need that because here they're asking, find the total profit when 60 seats are sold. So what we're going to do is to find P of 60. They're asking you to find P of 60. Profit at 60 seats are sold. We're going to integrate our marginal profit function from where to where? From 0 to 60. And then the function, can I go ahead and write the function as x to the 1/2 power? Minus 6. And then this is outside. Don't forget to put your dx. Okay, so I just had to rewrite it as a, I'll keep it as black pen, x to the 1/2 power because I want to use the power rule. Increase the exponent by 1. If you add 1 to 1/2, you'll get 3/2. And then remember, we have to divide this by the new power of 3/2, but this is looking bad. So when you are dividing by a fraction, the same thing as what? Multiplying by its reciprocal, right? So I'm just going to go ahead and say this is the same thing as multiplying that term by 2/3. All right, let's do the minus 6. That's going to give minus 6x to the first power divided by 1. So it's just going to be minus 6. And now we're going to just put these in a bracket. Put the 60 up top for the upper bound and 0 for the lower bound. Now let's evaluate this. Okay, let's evaluate this. Plug in two numbers. First, plug in 60 into your x. I'm going to plug in 60 into the x. Okay. I'll use the red pen for that. I will get 2/3 times 60 raised to the 3/2 power minus 6 times 60, right? And that's going to get subtracted by the answer that I will get if I plug in 0 into this x. Now, here's the thing, though. If I plug in 0 into this x, what will that be? That will just be 0, right? But still, because you may wonder, where did you get this from? I will go ahead and write it because I want consistency in my examples. 2/3 times 0 to the 3/2 power minus 6 times 0. And that blue term that I just wrote will just go straight to 0. So what I'm going to do is I'm going to go ahead and just evaluate this on a calculator because I noticed that 60 is not a perfect square. So I won't be able to get an exact answer in an integer form. And when they're talking about profit, I don't think they want an answer in a radical form. So let's go ahead and type this into our calculator to get the answer. Calculator over here. Clear it. So it was 2/3, right? 2/3 times 60 raised to the what power? 2/3, 3/2 power. 3/2 power. And then we did have minus 6 times 60. Okay? And the answer is coming out to be a negative 50.161. Now remember that, well, this is the answer. I'm going to write this down, but this was in, what was the unit? In hundreds of dollars, right? So I'm going to multiply this by 100 to give them the final answer. So what I know is that the profit is when 60 seats are sold, the Northeast profit is actually negative $5,016.13. What does that mean? The airline is losing money when they only sell like 60 seats, okay? That much money on a flight. So let's go ahead and write this down in our notes. Okay, so that did come out to be negative 50.1613. Whoopsie. 0.1613. And because the units were in hundreds of dollars, I'll say when 60 seats are sold, the Northeast profit, I do want to write down, is negative $5,016.13. How can a profit be negative? Well, that means they're just losing their money. That is, the airline will lose how much money? $5,016.13 on the flight when 60 seats are sold. Yep. So, and if we can tell that from this picture, notice there are more area under x-axis, right? And then there is less area under. Oh, what? I said, why wonder? Less area over the x-axis. That's why, I mean, we kind of expected to get this negative answer there. So in order for them to make more profit, they shouldn't stop at 60. They should sell more, right? Okay, so that was an example on profit and marginal profit. Let's go look at the very last one, example number 6. And I do want to come back and actually go over a couple of those review problems that I posted for you on Google Doc, okay, for your exam 3. Or the very last one, physical science braking distance, okay. Juanita is driving her car at 40 miles per hour. And look at what they gave us. That is 58.67 feet per second. I'm glad they gave us that, because when you're talking about stopping distance, you don't want the stopping distance to have a time unit of hours. A car shouldn't take hours to stop. So a car should take like a couple seconds to stop. When she applies the brake, when she applies the brake, that hits her speed. That is her velocity, really. So guess. Okay, I'm going to go ahead and use that as my initial condition later, but let's keep going. And the car comes to stop after 7 seconds. Okay. Her acceleration, remember guys, when we have the distance function, d of t, we take the distance function's derivative, and guess what that was? That was the velocity function, right? Oh, no. In this case, yep, never mind. And then if you take the velocity function and find the derivative of that, that is the acceleration function. So what we really just need is, I guess, this one. Velocity, if you take the derivative, you get acceleration function. So what does that mean? If you want to have go back to velocity, given a of t, you need to integrate it to get the velocity function. So what they are giving you here is that they're giving you the acceleration function is negative 2.394 t, where t is from 0 to 7 inclusive. Okay, so what do they want first? Find Juanita's velocity function. Okay, of course, we were expecting it. So they gave us the acceleration function. They're like, hey, integrate this acceleration function to find v of t. Oh, we can do that. Not going to put any bounds. I'm going to go ahead and put the plus c there, because I think I have that initial condition that I highlighted up there to solve for c. So what's the acceleration function? Negative, you know what, let me do right what I'm integrating here. A of t dt, right? That equals negative 2.394 t dt. Can you go over there and wait over there? Okay. Now I'm going to use the power rule. Okay. So negative 2.394 t to the second power, and we'll divide that by 2. And don't forget to put your plus c. Okay. Can you go ahead and divide that decimal? What is half of negative 2.94394? That will be negative 1.197 t squared plus c for right now. But here's the thing though, didn't they say when Juanita applied the brake, that moment is time equals 0. That very moment she applied that brake, her velocity was 58.67. So let's use that as the initial condition. So I'm going to change the pen because we're doing something a little different now. Initial condition given is that when time equals 0, when t equals 0, we have v of 0, to be 58.67 feet per second, right? When she applied that brake, her speed was, she was going 58.67 feet. So let's plug those in. So I'll say 58.67 on the left side for v of t. And we're going to plug in 0 into t. Now, some of you skipped that finding initial conditional work. Using this initial conditional work to find this constant of integration on your last daily problem work. And I guess maybe it was just too obvious for you that it was 0, 0, you plug in 0, 0, it comes out to be c equals 0. So I didn't take points off on that. But when you are doing your exam problem, please show me work on how you found that c value using the initial condition, okay? All right, let's solve that. Well, take a look. 58.67 equals, this will just give you 0, right? So C is 58.67. So we did find the velocity function. Let's give them the velocity function. Juanita's velocity function is negative 1.197 t squared plus, what number? 58.67. Awesome. Now, we're done with part B. Let's part A. Let's go take a look at part B. Let me label this part A. Okay, part B now. How far did the car travel while Juanita was braking? Oh, that's a good question. Now, but the thing is, if they want the distance traveled, I may have to just make this a little bit, now we got to go back to distance function. I'll just write it over here. Distance at t, if you take the derivative of distance at t, then that's how you got the velocity function, right? Now, if you want to go backward, if you have the velocity function, you're going to have to integrate that to go back to d of t, okay? So guess what? They're asking for how far did the car travel. They're asking you to find the distance. So we are going to now have to find the distance. So let's take a look. How far did the car travel while Juanita was braking? She was braking. She was stopping for what? 7 seconds, right? The car comes to a stop after 7 seconds. So she was traveling for that 7 seconds. So what we want to find is the distance she covered from t equals 0 to t equals 7. So we can go ahead and do this by setting up a definite integral, actually. So from 0 to what seconds? 7 seconds. Let's go ahead and integrate our velocity function. And we got that velocity function above right there, dt. And let us use the power rule over here. So what's that going to be? I think I should work to the side. Equals. And let me, guys, I posted about selecting the letter grade last night before I went to sleep. And a lot of people are emailing me about it. I think if you need to make a decision and kind of want to talk to me about what you are expecting, I mean, we got exam 3 this week, so I'll do my best to grade that exam 3 as soon as possible. But I know that's due on May 7th. Anyways, let me go back. T to the third power divided by 3, right? And then plus 58.67, what? T squared, and that's getting divided by the new power of 2. Now, I am going to plug in my bounds here, and the bounds are 7 and 0. I'm very out of room here, but what you notice is this. If you're going to have to plug in 7 into this place and that place, right? And then you're going to have to subtract the answer that you will get from subtracting 0 into those two places. But if you plug in 0 into those two places, that will just be 0. So we know the answer will just be negative 1.197, 7 to the third power, and you're going to divide that by 3, plus 58.67 times 7 squared divided by 2, because technically we have to subtract the answer that we get from plugging in 0. That will just give us 0. So, why not? Let me still write it. Minus 0, because you get 0 if you plug in 0, equals. Let me go ahead and type this into my calculator, okay? Let's do that together. Hold on a second. I was going there, but then I noticed something. Did you guys notice that too? This didn't have any t next to it. This was just a constant. So should I have a 2 there? No, I shouldn't. I'm sorry, I got distracted. I shouldn't up 2 there. All right, let me fix this right now. This is just going to be t, and there shouldn't be any new exponent there because I'm supposed to go up, increase the exponent by 1, not by 2. What am I doing? Goodness, I caught it. Okay, so that's what that's what I have to evaluate. So let me open up my scientific calculator and do that. Calculator. Clear. So the first fraction was negative, where's my fraction? 1.197 over 3. That was the constant, but we're multiplying that by 7 cubed, right? And then the second one was simply plus 58.67 times 7, and then minus 1, minus 0. So if I'd enter, I should get 237.833. And what was the unit? Her stopping distance. And this was in seconds, so not miles. No, it's going to be in feet. So 273.833 feet was how far she traveled while she was braking for the 7 seconds. So before she come to a complete stop, she still traveled that much. Okay, so that's very good. And that was it for 4.3, example 4, 5, and 6. And you know what, guys? I'm actually recording this first because I'm testing if my iPad can store longer, because I know the first 3 will take longer time. I'm going to go ahead and come back and post or record example 1, 2, and